Alright, so welcome to 1.6 notes. 1.6 we're going to be looking at inequalities, and to be exact, linear inequalities, because we have talked about inequalities before, but we did that with one variable, and we were graphing them on number lines. This time, we're going to look at inequalities with a x and a y, so multivariable, okay, two variables, and graphing these. And since there's two variables, we're going to be graphing them on coordinate planes, okay, like you see below. So the first thing is we're going to be determining if 2 points are a solution to the inequality. So we're given point A and point B and an inequality, and they want us to determine if they are solutions. If you look above it, it says in order to be a solution to inequality, the coordinates must make the inequality true when plugged in to the inequality. So what we're going to do is we're going to take these coordinates and plug it into the given inequality. So I'm going to rewrite the inequality over here. So we have y is greater than or equal to, I think it's greater, yeah, negative 2x plus 9. Okay. And remember, a coordinate, it goes x comma y. So we're going to now plug in our x and our y. So our y is 4, so this is going to be 4 greater than or equal to negative 2. Our x is 7. Okay, we can simplify. We get negative 14 plus 9. And negative 14 plus 9 is negative 5. And we get that 4 is greater than or equal to negative 5. That is true. So yes, this is, yes, this is a solution. Okay. Okay, now let's do another example. Okay, so we have our x and our y, and now we're going to plug it into the same, inequality. So it's going to be 3 is our y is greater than or equal to negative 2 times our x, which is negative 1, plus 9. So we get 3 is greater than or equal to 2, because negative 2 times negative 1 is 2, plus 9. So we get 3 is greater than or equal to 11, which is false. So it's not a solution, okay? So that's how you determine if something is a solution or not. Now, most of the homework will be asking you a graph, okay, these inequalities. So how we're going to graph them is first we're going to put it in slope-intercept form. So remember slope-intercept form. Let's write it down if you forgot. That's step 1. That's y equals mx plus b, okay? But since it's an inequality, it's not going to be equal to. It might be, let's make it into inequality. Y is greater than, okay, mx plus b, or less than mx plus b, okay? So that's slope-intercept form. So we first gain that form. And remember, when you multiply or divide by a negative, you gotta flip the sign. Then the second step is graph it. So graph how you normally graph a line, okay? But if we're going to use dashed lines if it's a less than or greater than sign, because that means we're not including the line itself as a solution. And then we're going to do a solid line if it's less than or equal to or greater than or equal to, because then the solutions on the line would include. Okay, you would be including your line in the solution. So solid means you're including the line. Dash means you're not including the line in the solution set. So let's first do number 1. So number 1's already in slope-intercept form. Okay, it's y equals mx plus b form. Okay, but instead of equal, it's less than. Okay, so let's graph it, and hopefully you remember how to graph these from earlier in the week. Okay, so you always start with your y-intercept. your y-intercept is at -1. Okay, so this is where I'm starting at -1. And then our slope is 2 over 3. So we're going to go up 2, right 3. So I'm going to put my point there. And then we're going to go up 2. So 1, 2, and then right 3. 1, 2, 3. Okay, that's I have a point there. And then we can also do this again. So we're going to go up 2, right 3 again. Okay, I have another point. And we can go in the opposite direction. We can go down 2, left 3. And you get a point over here. Okay, now we're going to connect our dots with a dashed line. We're not going to do a solid line because it's not equal to. It's just less than. So if it's less than or greater than, it's always going to be a dashed line. So let's just, I'm going to try my best to draw a dashed line on here. If it lets me. Okay. Okay. Now, inequality has multiple solutions, okay? Now, the solution set will be an area. It's not like when we graph lines, the line is your solution. Here, it's a whole area. And you have to determine, are you going to shade above or below it? Okay, so since it says y is less than, we're going to shade below it. So my solution set will be everything below the dotted line. Now, we can test if I shade a correct area, okay? But it's always going to be, if it's less than, you're going to be shading below. But let's double check by picking a point. So I'm going to pick a point, and we're going to make sure that point is a solution. So I know I shade the right area. So I picked, I think that's 0, -8. Okay, so we're going to test if that is a solution. So when I plug it in, I get -8 is less than 2/3 times 0 minus 1. Well, 2/3 times 0 is just 0, so we get -8 is less than -1, which is true, okay? So that is the solution. I did shade correctly. So if you want to make sure you shade it correctly, just pick a point on the area you shaded, and then you can check. Okay. Now, you don't have to check. I mean, if it's less than, you know you're going to be shading below. So that's just if you want to check, okay? I know some people even say, just pick a point anywhere on the graph, and then if that point is a solution, you're going to shade that area. If it's not a solution, you're going to shade the area opposite from it, okay? Now, number 2 isn't in slope-intercept form, so let's get that into slope-intercept form before we do anything else. So we want to get that y by itself. So let's subtract the x over. So we get -6y is less than -x minus 12. And then let's divide everything by -6. And since we're dividing by a negative, we got to flip the sign. So it's going to become y is greater than. So y is greater than, and we get 1/6x plus 2. Okay? Because -x over -6, that will turn in, if you're dividing two negatives, it becomes positive. So you get 1/6x. And then same thing with -12 divided by -6, that's just 2. So that's my new answer, or my new equation. And this is also going to be a dotted line because it's just equal to, okay? Now I put that dotted line so I remember it's dotted, okay? I always, that's the biggest mistake I'll make, is I'll do a solid line because I'm just so used to making solid lines. But remember, in an inequality, if it's less than or greater than, you have to do a dotted line when graphing it, because you're not including, the answers to the equation won't be true on the line. So that's why you want to make it dotted, so you know our solution set is not included in the line itself. Okay, so let's now graph this. So we start with our y-intercept. Our y-intercept is 2, so we start at 2. And then our slope is 1 over 6, so we're going to go up 1, right 6. Okay, so I get this point over here. And we can also go in the opposite direction, so we can go down 1, left 6. Oops, which should be down here. Okay. Now we're going to do a dotted line. Okay. It's not a perfect dotted line, but it's good enough. And we need to determine the what area we're going to shade. Now we're going to shade above because it's greater than. Okay, you always want to shade above if it's greater than. Okay. And then you can test a point. I'm not going to, but if you want to test the point, you can pick like 0, 8 and see if that works, if we shade the correct area. But it's just a way you can check your answer, okay? So now moving on to the back of the notes. Let's look at number 3. So we have x is less than -4. So let's rewrite this as just x equals -4, just for now. So I taught you hoi vux last time. And it's there to help you to remember if you see an x in an equation, if it is x equals a number, remember it's vertical. So this is going to be a vertical line at -4. So we're going to go at -4. And we're just going to draw a vertical line. Okay. So I always start by just drawing, we know that that's what the line should look like. But it says x is less than -4, so we're going to also do a dashed line again. If it's a x is less than or equal to, we would do a solid line, but it's just less than, so we're going to do a dashed line. And then we need to determine if we're going to shade to the left or to the right. Now, because normally it's up or down, but an example like this, if it's less than, you're going to shade all the numbers less than -4. So all the numbers less than -4 would be to the left, so we're going to shade to the left. Okay, because we're looking at less than. Okay, and you can test that. If you plug in -8 into this equation, -8 is less than -4. That's true. Okay. So you can test it out, and you get that. Try and figure out which one I want to do. Let's do number 2. So Scott makes $12 per hour babysitting and $8 per hour working at the grocery store. He will need to make at least $600 to buy a new computer. Okay. So we need to write some sort of equation for this. So, to get a text box. So above here, I'm just gonna write down my variables. Okay, so there's hours babysitting. We'll call that x. So x will equal. I don't know where the equal to sign is. Oh, here. X equals to the hours babysitting. Okay, and we'll say y. Y equals hours at grocery store. Okay. So I always like setting up my variables. Whenever you have a story problem, we know there's going to be 2 variables because this is a linear inequality, okay? You have x and a y. Okay, so you have hours babysitting, hours at the grocery store. Okay. So now how I'm going to write this equation is we know, we have, you get 12 hours, $12 babysitting, plus you're going to be given another $8 every hour you're working at a grocery store. So we get this, you get this 12x plus 8y. This is the total amount of money. And we need to make at least $600. So this needs to be greater than or equal to 600. Because it needs to be at least 600. So it needs to be either greater than 600 or equal to 600. So that's where I'm going to use this greater than or equal to sign. Okay. So this at least, whenever you see at least like this, you know it's going to be a greater than or equal to sign. Okay. So this is my equation. 12x plus 8y is greater than or equal to 600. Okay. Because 12x plus 8y represents how much money he's making, and then you plug in the amount of hours he has for, babysitting and how many hours he has at the grocery store, and we're going to see if that's above 600, okay, to test the solution. So now we're going to graph it. Now, we can graph it using our intercepts. And I think that's probably the best way of doing it, is graphing our x and y intercept. Because that's one way you can graph things in standard form. Because I don't feel like changing it to y equals mx plus b form. I mean, we could, but I think it will just be easier graphing our intercepts. So let's find our x and y intercept. And we'll find them down here. So let's let x be 0 to find that y-intercept. So if x is 0, we get 12. 12 times 0 plus 8y equals, and we'll just make it equals 600. Don't worry about when you're trying to find the intercepts, it doesn't matter the less than or equal to sign. We can just make it equals to sign. And then this gets us 8y is equal to 600. Okay, so if you divide both sides by 8, you get y equals 75. So our y-intercept is going to be 0, 75. Okay, so let's put that 0, 75. Okay, similarly, if you want to find the x-intercept, okay, you're going to let y equal 0. So let's let y equal 0. Okay, and if you let y equal 0, I'm going to just tell you right now what you get. If y is 0, you're just going to divide 600 by 12. You get x. You're going to get x to be 50. Okay. Now, this is a review, so I kind of went through that quick. But our second point should be 50, 0. Okay. So those are my two intercepts. We have one at 50, and then we have one at 75. So let's just, doesn't matter what these points, it doesn't have to be exact. So I'm just going to say over here is 50, that point right there. And then we'll say 75 is like up here. Okay. And I'm going to draw a solid line. Okay. Between my 2 points. And we're going to shade, because it's greater than, right? So we're going to shade above this line. Okay. Okay, and then it says for part B, so part A wants us to graph it. Then B wants to give us two possible combinations to ensure that he can afford it. Okay, so you would just pick any point in here. So it has to be over 50. Like how we can do this is we know if he babysits for 51 hours, he'll get it. Okay, he doesn't even need to work at a grocery store. So like one solution would be like 51 comma 0. That would be one solution. Or he could do he can babysit for like 50 hours, and he can work at a store for grocery store for 2 hours, and that would also be a solution on this line. Now, I didn't really do the graph justice, okay? But I'm not too worried about graphing that. I just mainly want us to revisit graphing the x and y intercepts and then connecting those, okay? But yeah. So, these are two solutions that would work. You can give, other solutions. It just needs to be in a shaded area, okay? So I just did values bigger than 50, and you can also do values like 0 and 76 would work, okay? And that many hours will get him more than $600 for that computer, okay? So if you have any questions, you can ask them on Monday or email me, okay? So hopefully you got time to work on some homework, and it should be very similar to the notes. So have a good day. See you guys on Monday.